All right. Well, you guys, thank you so much. I'm so glad that everybody's there in person. And I'm really sorry that I couldn't be there with all of you. It's been such a great pleasure to help plan this meeting with Dan and Amanda and so many others. Bilal, it's just great to see all of your faces. So thank you guys. Um, I guess this is one of my first meetings as a former NOAA person, similar to David before me. A few of us left NOAA in the last couple of months. But before I left, I was part of basically what I think Mary Claire was talking about in terms of our client relations. It was my job really to think about being the boots on the ground and knowing a lot about NOAA's portfolio and really thinking about building those deep relationships across the economic sectors, including those in insurance and also in engineering. So I'm really honored to have a couple of my awesome colleagues there today. Allison Crimmins and Maggie Coates are on the panel to think about and talk about what we had built together in the industry proving ground at NOAA. So using IRA funding and also projects using BIL funding, we were able to really capitalize on some of those relationships that we've had over decades with this industry, and to really move the ball forward in terms of what NOAA's data can provide. So I really appreciated the emphasis early on in today about our data and how we're transforming our data to really be useful for this industry. So this panel is going to focus on the data and the curation of products and the co-development of products between NOAA and the insurance and the engineering sector. So we have Allison Crimmins to go first. She's the executive director of the Industry Proving Ground as part of the National Centers for Environmental Information. She's in Washington, but the NCEI is in Asheville, North Carolina, as Dave mentioned earlier. And then we also have Maggie Coates, who's with Cadmus, and she's really our linchpin when it comes to the work that we've been doing with the industry sectors. And oh, great, I love it. Thank you for the slide, Maggie, who's created all of this. And then Dr. Jim Waller is also joining as the research meteorologist at Guy Carpenter, who's been a member of our small team, which I think Maggie will talk about, and Jim will also talk about his experience there. So welcome to all three of you, and thank you guys for being there in person. So I'm going to turn it over live to Allison first, and then I'll come back at the end with some questions. So I'm going to have to interrupt you guys on some timing, and I'll cede the floor to Allison first.
Thank you. And I think you could go ahead a slide or two since Ellen already introduced me so nicely. One thing Ellen said in her intro is that she was a part of this engagement work, but I think she was maybe underselling it. My first slide is only here because of Ellen's instrumental role in helping NOAA develop our service delivery framework. And it's an important place to start my presentation, I think, because I'm relatively new to NOAA. I just started, late last fall. And I have to say, one of the things I was most impressed by when I came into this role is the really continuous engagement that our group has with our industry sectors. It's not, I've been in the government for a long time, so I've seen a lot of instances where we ask people what they want, then we come back several years later and give them something and we hope you like it. That is not what this is at all. It's a really interesting and exciting opportunity to be very directly engaged in a continuous way with our industry sectors. So we are building trusting relationships. We are gathering user needs throughout our engagement with these sectors, translating those needs into requirements, assessing what sort of data and services are needed, but also figuring out how to make sure that we're continuously gathering input along the development of the different products. Then we deliver the products, and all throughout that entire process, we are engaging and evaluating how those products are meeting our users' needs. So I hope you're going to hear a little bit more about that from both Maggie and Jim here. Next slide, please. So the industry proving ground is a proving ground. We decided to start with 3 sectors initially. So those are architects and engineers, retail, and the insurance and reinsurance sector. And you know, I don't want to give the impression that this is a brand new thing. We have been engaging with a lot of the people here in this room, and also, you know, especially the reinsurance sector for many, many, many years. So this is a new innovative project, but I think we've had a long-lasting relationship between NOAA and many of these sectors. Next slide, please. Our engagement also takes many different forms. So I think several years back, probably when Rick Spinrad was kind of kicking some of this work off, there were some very large listening sessions that really was kind of big brainstorming, kind of everyone's in the room, you know, getting ideas out there to help us understand where some of the user needs are. And over time, we have worked with smaller working groups from each of our 3 industry sectors to help kind of take those huge long list of brainstormed ideas and to figure out where are the priorities within those user needs. And so that we do that through our working groups that we meet with regularly, monthly, every 6 weeks or so. We meet with our different industry working groups. We also have many conferences and tool cafes. If you have not already visited the tool cafe we have set up here, I really encourage you to, you know, it's right in one of those rooms by the food table. So as you're getting your food, just kind of wander in there. And you can see some, you can actually play around with and demo some of the products that we are developing as part of this work. And then finally, the workshops and webinars. One of the things that came out of the ASC NOAA workshop last year was that we heard from this group that there was a request for hazard-based webinars. And so one of the things we're doing is, with our architects and engineering sector, is hosting a number of these hazard-based workshops. The next one is in August, and it is on snow and ice, which is what we all want to talk about in August. So you are all very welcome to that one coming up. We don't have the exact date yet, but it'll be in mid-August or so. Next slide, please. So we did all these listening sessions. We did all of these working group meetings. We've had all of these interactions with our 3 sectors. We're about halfway through the Industry Proving Ground project right now. We've had around 33 engagements with our different working group and sectors. And we've heard a lot of different things. This slide tries to summarize some of the higher level things that we've heard from our working group. And then how are we translating those into the different products that we are developing. In some cases, that takes the form of improving an existing product and updating or modernizing some code. And I don't mean building codes, I mean computer code. In some cases, that is developing a new resource. So thinking about hail or wind climatology, that's not something that we have existing already on NOAA. I'll point you to kind of the last 2 items on this list here, which I kind of would summarize as make this information more accessible, please, and easier to find, and where you don't have to know the NOAA org chart to find where these data sets exist, and maybe also make the website not look like it's the 90s anymore, so that I can, you know, interact with and find and download the very customized information that I need. So my last slide, if you go to the next one before, oh, whoa.
Wow.
Well, that's interesting. Okay. What you would be seeing is we have around 20 products that are in some stage of starting right now, whether that's in kind of a scoping or research side or very close to completion. This was a table that showed you, I don't know, 10 or 12 of those items. And it was meant to demonstrate how a lot of products that we are developing right now meet the needs of more than one of our industry sectors. It was also supposed to show you somehow that a lot of these products are coming out on a rolling basis between now and next September. And we have several items that are either coming out this summer or in the next couple months. So please be on the lookout there. One of those is that we just updated our website yesterday, And so Maggie, I think, has on one of her slides the website that we've built that has kind of individualized sub-sector websites. So you can go just to the architect and engineering or just to the reinsurance website and find all of the tools in one-stop shop kind of place for each of those sectors. And so with that, I will pass it off to Maggie.
Thank you, Allison, and thank you, Ellen. So my name is Maggie Coates. I work for the Cadmus Group, which is a consulting company that works with NOAA on the industry proving grounds. I am the user engagement lead on the contract end for the IPG. And what that means is I get to come to events like this and work with people like Ellen and Allison, and I have a couple of my teammates in the back who truly know the science behind a lot of the work that we're doing and are working to actually do the coding and the building of the products. And I get to come and make sure that the products that we're developing are what you need them to be. And that's part of that service delivery model that Allison spoke to. And so we have done a lot of work, of course, with ASCE over the last year, and a lot of you have been part of that. Again, I'll shameless plug the room that we have going on. It's right by the food. It's really easy to find, and we'll be here today and tomorrow during all of the breaks to show some of the products that we're working on with ASCE. But some of the products that I want to talk about today are the ones that we've been working on with the reinsurance and insurance industry specifically. And so I have 3 different products to pull up here, and we can show you a little bit more if you do want to talk more after this about these specific products. But there are 3 really different levels of development. So this first one, if we go back one, okay, I see what happened. Sorry, Ellen, we can go forward one. There was a slide here before that shows, speaking of websites that look like they're from the 90s, this storm events database. Is anyone familiar with the storm events database in existence? Couple hands. So that has been around for over 25 years. And this is the exciting new and improved storm events database that we've been working on for about a year now, a little over a year now.
That's all.
We should be good. Okay, and all good. The storm events database has been used for a long time. One of our primary use cases that we talk about is the need for reinsurance companies and insurance companies after a storm to have an authoritative source for, did this storm exist in your area, when we're validating a claim or building out models. And so the new storm events database, if you use this QR code, which I know some of you are already a step ahead, this is why I had the old slide, so you couldn't skip ahead. This QR code is the new storm events database that you can only use with this link. If you were to Google storm events database or go on NOAA's website right now, you do not have access to this. So take advantage, write it down, or we'll send it to you, and you can share it with your colleagues if you want to. But this is sort of the version 1.1. We are continuously updating it and gathering feedback on it. And some of, as Ellen and Allison both mentioned, our core team that Jim has been a part of, is we sat down and we said, what does this product need to do better? And we learned that it needs to have a mapping interface. It can't just have a bunch of text. We need to be able to have bulk data access for all of the different storm types. And so now you can go on and you can take your mouse and you can draw a circle around an area, or you can type it in by zip code, filter a lot of different ways, and then download the data. We've also made it so that it's a little bit more user-friendly for first-time users, so there are new user guides. Just the website overall is a new interface. So take a look at it. Please let us know if you want to talk more about it or provide some feedback on it, because that's something we're in the process of doing. If we go to the next slide. So this is our event catalog product. The event catalog is not an old product that we're giving a facelift, but it's actually a new, really exciting major product that we're working toward that's sort of a supplement to the storm events database. So the storm events database has over 40 different hazards. This product at baseline under the industry proving grounds will have just a couple to start. But what we've been hearing for a long time from the insurance industry is that we need footprints. We don't need just single points. We need footprints for storms so that we can actually trace where they are. And so this is a very early stage mock-up. And we're working with Jim and the greater reinsurance team to decide what does this really need to do and what do you need to be able to pull. And so you'll be able to similarly go on the map and see actual footprints of things like tornadoes, severe storms, and hurricanes, and be able to pull that information afterwards. Within just a couple of days, probably 3 to 4 days, there will be a storm report here. So it's a supplemental tool. They really can be used hand in hand, and that's something that's in the early stages. I don't have a fun QR code for you here, but happy to talk more and kind of get your input if this is something that anyone would use. And if we go to our final. This is an image of a wind climatology mock-up. Again, this is in the most early stages where we're sort of in the scoping process. And we know that there is a need for more and better wind data of across the country. What this will essentially do is it's a partnership with the Western Regional Climate Center, who has built out the IRMA data set for quite a few different features of wind. And then we, as part of the industry proving grounds, are building out the web interface for that. And so we're working to see what are the actual analytical pieces that are needed. And this is what we're working with Jim's team on. Are we sort of missing wind data that needs to go in here in addition to the IRMA data set? Are we looking at the right regions and the right resolution, because that's been the big question and the big thing that's been needed through our engagement. And then finally, this is my further pitch to go talk to us about our other products. Adriana, if you'll raise your hand. Adriana is sitting there in the back, and she's in the room as part of our tools cafe. Adriana has been a big spearhead to the typical meteorological year product, and that's something that is being developed in coordination with architects and engineers, and is something that I know she'd love to talk more about. We are also in the early stages of a precipitation time series explorer, just a mouthful that I think that's like the third title we've given it, but I think that's what we're sticking with for now, using the MRMS precipitation data. And so would love, beyond just the reinsurance products that we're working on, to give you a chance to actually pilot. If you go into the Tools Cafe room, the typical meteorological year is behind NOAA's systems. You can actually play with it. We can't give you a QR code, but you actually can look at a lot of its functionality beyond just a mock-up here. So those are some of the many products that you couldn't see on Allison's slide, but it has been a really large effort over the last year, and we have about 15 months left of this project, so a big push in the next couple months. This is the QR code that Allison was referring to with the new website on it, so please go ahead and take a look at that. And with that, I'll pass it to Jim.
Thank you very much, and good afternoon. It's a pleasure to speak with you all today. Do people need more time with that QR code, or are we good to go? Okay. How does my slide look?
Better than mine.
I've seen worse. Okay, I'm going to open by level setting on some context about how we use NOAA data and what we actually use it for. And for that context, I'll direct your attention to the picture behind me, which shows global insured losses. For those loss events that produced over 100 million in insured losses, broken up by hazard that we in the insurance industry call peril. And that's from 2013 through first quarter of 2025. A few things to draw out. One, that is not a downward trend that we see in this picture. We're all quantitatively situated in this room, or most of us are, and if not, that is not a downward trend that we see. The other thing to point out is that from year to year, global loss activity shows a great deal of variability, which makes it hard to assess statistical significance for any trends. And that variability gets even louder when you think about the individual contributors to the overall losses on an annual basis. The red that shows wildfire has different thicknesses from year to year. These losses, by the way, are not adjusted for inflation or population growth. These are just raw insured losses. Severe thunderstorm, which is the blue that you see at the bottom, was mostly squares early on. It is mostly long rectangles now. So severe thunderstorm is costing more money for the insurance industry. And again, these are loss events that produce more than 100 million in insured loss. So there's missing money in this picture that is quite often being picked up by insurance companies themselves. They don't tap into reinsurance structures. And that's eroding capital on a regular basis. So when we think of the previous speaker from this morning showing loss ratios over 100%, from about 2017 onwards, the capital dimension can help with that to offset the pain for insurance companies. But as your capital reserves erode, it makes a company less likely to be able to withstand the big one when it hits. We saw examples of that in the state of Florida and the state of Louisiana in 2020 and in 2021, where severe thunderstorm just eroded their capital reserves bit by bit by bit. And when then Hurricane Ian hit, or Laura, or otherwise, in addition to the 6 landfalls that we saw in 2020, it unfortunately put a number of carriers out of business. So this stuff is very, very real. Why do we care? Because policyholders cannot get paid if an insurance company goes out of business, regardless of how you feel about the insurance industry. We can talk more about that at the bar later if you want. The hurricanes are costing more. 2017, we saw a spike with Hurricane Irma, which had a very large footprint. It produced catastrophic losses in the Keys and in Southwest Florida, but it had a big, big footprint, producing low-grade losses over a very large area, which was very impactful in the aggregate. And we're seeing that with other hurricane activity in recent years. So with that context, how do we in the insurance industry assess what normal is? How do we identify what our expected loss is on an annual basis when we look at a picture like this? Well, the answer is that it's hard. One of the tools that we turn to is catastrophe models. That subject has come up a few times today. A catastrophe model is a way of estimating annual insured loss. How much can I expect to lose in insured losses on an annual basis? But also, what is the average of my peak events? How often should I expect a Joplin-like tornado event? Or, God forbid, an EF4 tornado hitting the Chicago metro area, which is physically plausible but unobserved. What would that cost? What would the implications be? To develop these, we generate hundreds of thousands of physically plausible but unobserved events. So if you think of hurricane, I would produce hundreds of thousands of synthetic hurricane tracks. We haven't seen a live landfall in the state of Delaware since 1900, but if we borrow information from surrounding states, we can fill in the gaps by creating synthetic events, producing a wind footprint around those. Once we have that, you can estimate site intensity and apply that to an exposure, to a hotel, maybe a house, maybe a steel frame commercial structure, to estimate the degree to which it would break when subjected to that hazard. Same deal for wildfire, maybe for hail, maybe for flood. So synthetic events, to what extent should things break when subjected to those events? And then you couple that with how much it should cost. Do we account for the differences in construction type? Absolutely. Steel frame, concrete, wood frame. We do distinguish between mobile home versus manufactured home. There's a difference between the two. Year built, number of stories, occupancy type, and the recipe, the soup of building codes that determine the degree to which things would break when subjected to those physical hazards. We use that to then estimate how much it would cost. And that taps into reinsurance. How do we calibrate these? Well, according to building codes, not only are they in play, but also are they enforced? The Institute for Business and Home Safety has a really, really good overview of those factors and how they play out from state to state, and there are some distinct differences. And we also calibrate according to industry losses. Are cat models infallible? Absolutely not. A mathematical Puritan would say that we should all go home. There are three classes of catastrophe model in my view. This is informal. There's wrong, there's less wrong, and there's useless. We like the middle category. So how do we calibrate these models? Well, I talked about building codes, but we also rely very closely on scientifically defensible and vendor-independent, neutral, objective data sets of research grade to calibrate these models. Turning back through history, looking at the HERDAT2 database, how often might we expect a Category 3 landfall in certain parts of the US, or maybe on a global basis? How often might we expect an EF4 or higher tornado in the Northeast? It is a question that comes up. So that calibration element is critical. I want to make sure that I don't miss anything because I'm trying to look out the back of my head and it's not working so well. The other important point is that a model can only be so good as the science and engineering knowledge supporting it. These models are out of date as soon as they come out of the box, because once the science is frozen, once the science and engineering underpinnings of the model are set, the software developers have to close the loop. And that can take anywhere between 8 to 18 months, depending on the model. And by the way, you want the software to run in less than a year. You want it to run within 24 hours when you're doing an active reinsurance placement. So you have to make some sacrifices along the way. We use other tools to help to backstop the models, hazard surfaces, raw data from NOAA agencies, depending on the flavor of hazard that we're dealing with. Same thing with USGS, the wildfire agencies, both state and federal. And we use that for alternate lenses on how a book should approach pricing and underwriting, and also for active reinsurance placements. If we go to the next slide, I'm not going to read all of this to you. It should make your eyes hurt because there's too much there for a live presentation, but please take this home and look more closely at it, because there's a good overview of the data sets that we use in the reinsurance industry. For hurricane, HERDAT2, HERSAT, for live events, we use the ATCF. Post-event, we use tools such as the NOAA Damage Assessment Toolkit, both for assessing the efficacy of the catastrophe models and for calibrating them, but also for live events, both of which are important flavors of what we do in the insurance industry. We use that to bench test models that are quite out of date. The update cycle for hurricane is every 2 years. For severe thunderstorm, they are 10 years out of date, and we have frankly seen some changes in the science and in the observational baseline since then. So we use these data sets from NOAA to help recalibrate the models so that they are more reflective of the current view of risk. And along the way, we need to help the companies that we work with at Guy Carpenter, which are primarily insurance companies, with how to think forward about these physical hazards. You could argue that the building stock and infrastructure in the United States is not equipped for today's climate, let alone what we might expect under climate change. So we turn to views of the projected hazards and how they will evolve over time, again, to recalibrate the models, to think forward, to provide a projected view of what we should expect for annual insured losses. How should we expect that to change? How should we expect extreme events to change over time, the worst of the tail events? Those changes are most apparent for the coastal hazards, for storm surge, for inland flood, maybe hurricane intensity, less apparent for certain others. Severe thunderstorm is a bit murky. Part of it's because we don't know what normal is for hail, but we're getting there. There are some fantastic tools that have been made available over the last 5 years with NOAA, with some remarkable developments through informal conversations, and lately with the Industry Proving Grounds initiative. We view the NOAA Coastal Hazards offering and the Sea Level Rise tool as really one of the finest offerings that they have given to allow those users without a meteorology degree to get a holistic view of the hazards now, but how they are projected to change. And it's also useful for live events, and we would love to see that sort of effort continue. And there's some fantastic efforts already in the works that my colleagues here mentioned today. So thank you for the time, and we'll turn it back over to, I believe, Ellen for her comments. Thanks.
Oh, you guys, thank you so much. Jim, thank you for that call out on the Coastal Suite. I just want to acknowledge that we have Doug Marcy, Jamie Carter, Supriya Kadki and others from the Office of Coastal Management that probably really appreciate your comment about their flagship products and sea level rise. And I just also really want to thank you for that that deep explanation on risk and how it's calculated, especially with the CAT models. Hopefully that's really helpful to this audience to have an understanding of the flow, what NOAA is doing in this partnership, and also just a deeper understanding of the intersection. I'm sorry that we didn't get Allison's slide there to work about the intersection really between what we're doing with architecture and engineering and also what we're doing with insurance. I want to just ask a couple of questions, and while I'm talking, I hope you guys have time to enter your own questions into the question box online, but also in the room. So I just had a couple here. One is back to Allison, because of course, well, I guess let me start with Maggie. Let me start with Maggie because part of the NOAA ASCE partnership and really the industry proving ground too is this concept of co-production, building scientific products that are to be used by these two sectors, engineering and insurance. And I was wondering if you could just spend a little bit more time, Maggie, on how the IPG is structured to include that co-production.
Yes, thank you, Ellen. So I'll use an analogy that Ellen really likes to use, and I've stolen from her on numerous occasions. You already know what I'm going to say, which is that in co-production of products, we look at this model where we go from a skateboard to a Ferrari. And as Allison kind of mentioned earlier, oftentimes we see people ask, what do you need? And then come 10 years back with a Ferrari that, you know, you're driving on the wrong side of the road or something. The steering wheel's on the wrong side. And so what we did was we've almost started backwards, where we started with we have a core team or a working group with each sector that we work with of our professionals who we know have engaged with NOAA before. And we started off almost saying, what is your Ferrari? What is your absolute best case scenario that we could give to you? Knowing that in the constraints of a 30-month project, we can get you as close as we can, but then we go back and we say, now what do you really need from that? What is your sort of step one? What is your skateboard? Because we don't want you sitting here for 10 years with nothing to work with. And so then the next time we meet with them, we bring them one of these mock-ups or something, and we bring them this skateboard and we say, what's wrong with this? What does it need to do? What is it doing right? And then try to provide them maybe just the data up front as something that you can bulk download off of the NOD or start putting it up on the cloud, but maybe there's not much of an interface to it. And then we continue to work over the course of this industry proving grounds, and this is why it's called a proving grounds, because it's this fail fast model of get you to the next level, get you to the next sort of capability with this data. And so we might then take it to a broader audience, like something like this. We might bring you into a room where you can test out a product that's better than a skateboard, but maybe not quite a Ferrari. I think I've used Honda Accord before. is really sort of the happy medium. But then we might take it even bigger and then put it up online where your network, so not just the small working group or a group of professionals like this, but your entire network and the public can go see this product and provide feedback on it. So it's cyclical, where the industry proving grounds starts off really small, but we're not just going to gym with this final product 10 years from now. We're starting asking for that feedback from day one from industry professionals and going from there.
Thanks, Maggie. So one of the questions was actually a request to turn off my camera. So if you just saw me disappear, it's because I turned it off so that people could see the slides. But maybe now that we're on the Q&A, maybe I'm a little late to that. So I'll put myself back on.
Hey,
Thanks,
Alan?
Maggie.
Alan?
Yeah.
Yeah, this is Dan. I assume you can't see people in the room. So if somebody in here has a question, I'll let you know, okay?
Great, Dan. Thank you so much. All right, just a couple more questions, and then I'll turn to the folks in the room. So there is a bit of an elephant in the room here, and that is, this project. People keep talking about it as a 30-month project, and now they're saying they're halfway through. And there's a question really about, if we were to if we were to have an understanding of the future, what does that mean for the future of the IPG project? And so I want to ask Allison if she could just make a comment, because I know people are probably wondering, what are NCEI's plans to continue this engagement with some of the industry sectors, either with the IPG or something else?
Yeah, I will try. I'll start with the caveat of everything I say could be proved wrong tomorrow. Because I think we are still in a time of a lot of uncertainty across the federal government, within our agencies. So things are still shifting quite a bit, as I'm sure you can all see and understand. I think we're in kind of a lucky position here that we have this program that has been funded through September 2026. So we have this fabulous team of contractors who are forward funded. And the current plans right now is to keep moving forward and keep developing these products and keep doing what we're doing. It does align with a lot of calls for economic prosperity and improving partnerships with our industries. So I think there's a little bit of hope that what we're doing aligns with the larger picture, let's say. I will speculate a little that I don't want to paint this as overly rosy, because we are seeing a lot of cuts to our staff. We're seeing cuts to some specific products or programs. And so I think one of the things that I imagine we will be less able to do is, as we're entering sort of this second half of the industry proving ground, I was hoping that we would be really turning to a lot more communications and making sure that the folks within each of these sectors, beyond just our working groups, know about all these amazing tools we're developing, really taking things on a roadshow. But even beyond the three sectors that we chose for our initial industry proving ground, a lot of these tools we're developing are useful to many sectors beyond the three that we've chosen. And I think, with some limits on travel, with some limits on our opportunities as federal employees to communicate that, I will look maybe towards the people here on this, in this meeting, in this room, on the call, to help us spread the word about some of these tools and make sure that your audiences are learning about them. And invite us to do your demos for you. So that we can help get this information to a broader community.
I'll let a quick
Thanks,
follow-up. Allison, appreciate the comments. One of the things that's really stood out to me through this effort, and a collaborative effort, is taking available data sets from NOAA and making them increasingly tailored for consumption by the general public, so that we require less and less of a technical background in order to use them. One of the roles that we can play at Carpenter is helping the companies that we work with to be more aware of these tools as they come available, so they can use it for their own internal purposes. And I can assure you that the demand is there within the insurance industry. We have a good R&D team at Carpenter with about 10 to 12 people. So do the other titans that we work with. But there are many single state and multi-state mutual companies that do not have the benefit of those teams, and they can absolutely benefit from not only existing tools, but the tools that I believe are more adaptive and that we have seen under development through the IPG. Thanks.
Oh, Jim, you took the question that I was sending to you. That was awesome. And that's exactly it, is that we're really hoping that folks like Jim, who's on our team, and other members of the team will be able to expand. This is sort of like the old, I'm going to date myself, but the old double mint commercial, right? Like, you tell a friend, they tell two friends, they tell two friends. So definitely get the word out about the work that's being done here and the products that you've seen. They're, like Maggie said, they're in various different levels of development. I guess, Jim, my other part, I had a multi-part question for you. One was, can you comment on your experience with the team? But you kind of did there. But I wonder if you might comment on who's not in the room that you would suggest would be another voice that we should consider in terms of resiliency and insurability. I know that we've heard, this question is kind of getting at some of the prior panels that we've heard today, and thinking about the role of insurance versus the role of investors, and I think we have some of those folks in the room and online, and I'm wondering if you are seeing a missing element based on your experience.
Personally, I don't see anything missing. I'm sure I'll think of something after I leave the room today. But I think you touched on some of the essential agencies. Insurance and availability of money post-event is an important piece of it. I think investors, those that are looking to deploy capital to help with disaster resilience. Private and public sector agencies seem to be represented here. That is so essential with a recovery effort. I think what's really important to keep attention to is relaying the importance of these measures and these data sets to the general public wherever possible to help with their own decision making. Thinking back to an earlier example, if they're thinking of buying a house and they're hedging on whether to invest a bit more for a more resilient home, perhaps meeting the IBHS fortified standard, that cost benefit element is so important to that decision. We've seen it borne out with the people in this room. We need to relay that to the public at every available opportunity. And that, I think, is something that can help to drive this conversation forward. So a bit of a sideways answer, but hopefully helpful. Thanks.
No, I think that's really great, and it really sews together what we've heard from the other panels. I mean, we have the fortified standard when we think about fire resilient homes, but what we really need is a fortified standard for different perils and their resiliency. And I think that prior panels have said that. So I really appreciate that work from IBHS there. I don't know, Dan, if there are other questions in the room. I had one more.
Definitely.
Thing. Good. Let's go.
Easy.
I can't call on anybody, so you may have to, Dan.
Hang on. Can you hear the question? Is the microphone on?
Is this on?
No,
Can you hear me now?
I did not.
Okay.
Can you hear me? Okay,
Introduce
great.
again.
Terry Smith, Ellen from Smith's Research and Gradings, and we've been a big fan of everything you've done. Everything from the, you have the surge over land modeling that we do for a preparation for hurricanes. We have our own slosh model with a 3D underwater view in terms of like harbors and areas. We like to think that we can get out of the way of the storms or the damage before they hit. And by that, I mean, as an investor, we sell and get it gone. We're gone. So when before there's a gunfight in Dodge, we like to be gone and we're moving on. So there's that element in terms of just, we don't need the insurance because we're not going to need it, because we're going to be gone because of what you do, because you provide us with that kind of information that's really actionable, investable intelligence, and that's our play it forward, scenario-based investing models. So that's something we are grateful for. If there's something in terms of endorsements, I think you should, look to that from people that are using your data, have benefited from it, and as I said, made a lot of money, and there's something that should inure to the benefit of NOAA.
All right. Thank you, Terry. Was there a specific question or just that suggestion?
I just want to say thank you.
Okay, you're fine. All right, go ahead, Jimmy.
Yeah, sure. Jimmy Durkin with Zurich Insurance. I'll also say thank you. I use a lot of these products on a daily basis, and I think the plan to modernize and make them more user accessible is great. I think that's probably the most consistent complaint I run into, so that's a great idea on the whole. Specific question for the group, though. When it comes to wildfire hazard modeling and mapping, is there any projects planned or underway already in that regard? Something that I've seen in the insurance industry is that our wildfire hazard models don't particularly do a great job, and I think some of the major fire events that we've experienced show that exactly. Calling area unburnable that has burned to the ground is not a very good hazard model at the end of the day. I think there's a lot of reasons why that happens. Wildfire is probably one of the most dynamic natural hazards we face. However, I'm curious, is there something that you all are looking at in that regard, especially to look at things like smoke and ember spread, which is where a lot of our commercial losses tend to originate from?
Okay, I'll start and then I'll have her fill in the blanks. Wildfire, I believe, is one of the hazards in our storm event database. So that exists in that tool. That's historical. It's kind of on our longer wish list for the event catalog, which is that footprint one. But I will say it's lower on the list of priorities that we've heard from our users. So as we're developing that tool and we're thinking about the skateboard version or the bicycle version, I think we're looking to severe convective storms and hail and hurricanes first, but with the hopes of eventually getting wildfire, setting up the framework so that wildfire could be added to that tool. Do you want to add?
Yes, I would just add the one other one that we're looking at specific to the IPG is the wind climatology, where wildfire wind as it impacts wildfire. And that's something that they're sort of trying to figure out whether we have that available sort of in the next 14 months. But I'd also add to that and Ellen and Allison have both sort of touched on this, but the IPG is not operating in a vacuum where we're sort of rebuilding all of these NOAA products. And so questions like this are ones that we keep getting, and we've gotten, you mentioned the coastal hazards data, where we're not the coastal hazards experts because we have an entire OCM doing coastal hazards. And so what we did when we started hearing questions like similar questions but related to coastal hazards was we said, let's get everyone together in the same room and figure out what products are actually under development at NOAA elsewhere, and do a webinar and have, get those questions and answers out there. And wildfire is something we're considering doing the same thing with, because we don't necessarily have the resources under just the IPG to do that, nor are we the experts when there are so many other people at NOAA who have been at NOAA for so long who are doing that. So would love to talk more afterwards there, but that's sort of our
Well, I guess I'll just
page.
I could do a quick.
Yeah, I'll chime in on that too. And thank you, Maggie, for raising that, because we do have some great colleagues that are part of the wildfire test bed that's based out in Boulder, Colorado. That's part of NOAA, and they're part of an interagency dialogue around wildfire, which you've seen in the news. And then additionally, we did do a webinar series that included the weather timescale and climate timescale around products that we have for wildfire. So I would encourage you guys to take a look at nrcc.cornell.edu and go to the insurance dialogues, and you'll see the first webinar that we did a couple of years ago about some of the wildfire products at NOAA. So I encourage you to take a look at that.
Ellen, quick follow-up.
Dan, I'm not sure if what? Sorry?
Ellen, could I do a quick follow-up?
Yep.
Thanks.
Hi, Jim.
The other element of wildfire is that it's just really hard to model. It accounts for extremes in temperature, moisture, fuels, local geography, elevation, terrain, but also how it interacts with our urban environments. And the CAD model vendors let their wildfire models sit for a number of years. They've just done some recent updates, and they're still not getting it right. They're in a better place than they were, but they're absolutely not all the way there. We've developed some of our own indices at Carpenter to get ahead of some of these issues. We've developed an urban conflagration index that accounts for a number of the factors that we just talked about. And that interaction, I think, is the tricky bit, especially when you think about those low probability, high severity events like we saw in LA earlier on this year, which, by the way, happened after we had talked about priorities for the IPG, but we'll find a way forward. But hopefully useful perspective. Ellen, thanks.
All right, Ellen, I've got a couple here in the room. Go ahead.
Okay, Dan, it's up to you to manage that then, because I know that we're a little bit into the break here. So.
You're good, and we've got a few minutes here before the next session. So
thanks.
Great, thank you.
David Frost, Georgia Tech. Earlier presentations and even the most recent ones here, there's a message coming across that we have lots of data and we're developing tools to analyze that data and understand that data. My perception, however, is that most of that data pertains to the stressors. And I actually feel that we've got a pretty large dearth of data in terms of the targets, and whether that's the infrastructure or other parts of it. So, for example, particularly for the folks here, how are you, to get a true sense of resilience, you have to understand both the demand and the capacity. So how are you bringing the capacity side into your thinking?
So I'm going to turn that one to Jim. Maybe we could talk about the asset classes. That's a proprietary set.
Thanks, Ellen, I think. We turn to publications along the lines of Stephen Strader out of Villanova, he's coupled views of population and physical hazard and looked at how they interact both under present and projected climates. And one of the tricks that we've learned along the way is to think about the population element in a company's market share relative to that population to make some decisions. You brought up the capacity element. That takes on different dimensions depending on what you're talking about. If it's infrastructure, to what degree can we stress the power grid? To what degree can we stress the water system or sewerage? If it all goes out, do we have a sustainable community? The answer is probably not. To what degree? The other dimension of it is how much does it cost? The other element of capacity comes in terms of the willingness of investors to backstop the risk for wildfire, for flood, severe thunderstorm, otherwise. That came to a choke point in 2023, but has relaxed a bit since. There is interest among investors to make capacity available to backstop risk, but in a very guarded form, and they want it consistent with the level of the physical hazard. I welcome other thoughts to backstop what I just said.
Dan, I have some thoughts on that.
Was that David following up?
I think a key item, my name is Bilal Ayoub, University of Maryland professor. A key item is really correlation. And I was hoping to hear more about that, because I think when we have, and in simple terms, if I have two assets and the mean loss, let's say, is equal, the total loss of the portfolio will be 2 times the mean. The variance will be 2 times the variance. But if they are correlated, it's 4 times the variance. So actually, if they are fully correlated. So the variance grows tremendously when things are correlated. And the fundamental question, how things could become correlated. In fire, there is basically the fire spread, which will create that correlation. A building code will create a correlation. Current practices will create a correlation. What's your take on the correlation? So this brings it to the capacity side. If we have a hazard and the assets are correlated, the variance will become significantly larger. When you see the plot, the NOAA plot, where there is an increase, you wonder if that increase is really an average increase or is a variance increase. What's missing in there is the number of incidents, right? So the variance requires a careful examination and ways to maybe influence that correlation if possible at all.
Response from anybody?
I agree. That's actually one of the points that I forgot to speak to on my first slide. But when you think about what's caused the increase in insured losses over recent years, a big portion of it is due to economic factors. There was inflationary pressure in 2019. It got worse during the pandemic. The cost of building materials and labor has increased. The gentleman this morning raised a point that our populations are more dense and our population footprints are larger. So there's more to be broken. It's costing more to fix things when they break. And there are some changes in the physical hazards. And when you couple those three together to the correlation point, that explains in large measure the increase in insured losses. And there is missing money that insured losses don't account for at a societal level too. So the short version, again, I agree.
All right, excellent. Okay, I've got a question. And really what I'm doing is I'm kind of doing a little bit of a lead into a discussion that's going to be tomorrow. Tomorrow afternoon there's a session that's very similarly titled, but it has a slightly different focus in that it's products and services for architecture and engineering. And so the reason why there's 2 different sessions with similar titles is because there's a little bit of an assumption that the needs of the insurance industry are a little bit different than the needs of design engineers and architects. So I guess since you're here, Allison, and you've got this group, we talk a lot about, these services for insurance are going to be helpful for architecture and engineering, or architecture and engineering has been involved. But, could you speak a little bit to, I don't want to put you too far on the spot, but you've already agreed to be a little bit on the spot. One of the big things for engineering design is projections, future conditions. So do you see synergies? Is there an opportunity for synergies between insurance and these design issues that architects and engineers deal with? And can you tee it up a little bit for the discussion we're going to have tomorrow?
Yeah, I mean, I think future projections are important to all 3 of our sectors. I haven't really talked about retail at all in this but I think across all three, I would say architects and engineers are the loudest of our three sectors looking for future projections, since, of course, you're building something that's going to last 30 years. It might be nice to know what the, how much rain's going to fall 30 years from now. And so some of our products are working to sort of connect historical to future projections. I think that's really important on the insurance side. While they do use a lot of the historic to understand how trends are changing, I think understanding how many disasters you might expect each year, 10 or 15 or 20 years from now, that sort of planning. And same with retail. Oh, your stores face electrical outlets from extreme heat events like this week. Well, how many more times can you expect that in the future? Or you get your cotton from this place, can you still get cotton there 10 years from now, 20 years, 30 years from now? So there are cases in all three sectors where those climate projections are really important, particularly for the people who are thinking about long-term strategy.
Yeah, Erica?
We've got one more question from Lou, if you want to unmute yourself, and then that's going to be the last one for this session.
Yeah, this has been a great discussion, and I think it, in terms of being able to do a lot better cat modeling and risk modeling, the thing that gentleman from Georgia Tech really hit on it, the vulnerability data, I think that's a huge opportunity to bring the A&E firm into the picture, and it's also the thing I think that will assist in motivating incentives to help pay for resilience, because if you can capture the influence of reduction in vulnerability across the board, infrastructure, buildings, support, response recovery, into those CAT models, including the correlation, because obviously, and the wildfire example that was raised earlier is a good one. My house's vulnerability depends on the combustibility and housekeeping of my neighbor, even flood. I protect my home, but I drive the water into another home. Those kinds of things I think that's the next step, and it's a great discussion, and I think it's a good opportunity for the community to come together.
All right, thank you, Lou. All right, well, we're ready to turn to our next session, so a big hand for our panel. Thank you, Ellen. Wish you were here.
Thanks, everybody.
Yep, we miss you.
Thank you. I wish I was there too.
Okay.
So with that,
So if David and Chuck are here, if they could come up to the front of the room, and then Daniel and Ron are online.